Okay, class, we're going to take a look at some more tools that we have to calculate exact cosines, and we're also going to look at proving it. So sometimes when we just take things for granted, we use them, and sometimes if you take a look at how it's derived, you appreciate how it works more. So we're actually going to take a look at this and then talk about how we can show that. Okay, one of these theorems says that if I take two angles and add them together, I'm going to get the same result when I take the sum of those angles as I would get if I took the independent angles, multiplied their cosines, and subtracted the product of their sines. So we're actually going to start and prove this one, and then we'll see how this one derives from this one. So let's take a look at proving cosine of alpha minus beta equals cosine alpha times cosine beta plus sine alpha times sine beta. Okay, so let's start with these two pictures. We're going to use these to help convince us that that rule works. So we're going to declare a couple of angles here. The alpha stretches over here. So because this is a unit circle, we know that the point on the circle is the cosine of alpha and this for x and the sine of alpha for y. And we're going to let beta be this angle that terminates before alpha. And we know that x is the cosine of beta and y is the sine of beta. Okay, so if this is alpha and this is beta, then the difference between alpha and beta, alpha minus beta, is going to be this angle right here, because I'm taking all of alpha and I'm just chopping off the beta part, and that leaves everything between this terminal angle and this terminal angle to be alpha minus beta. Okay, so what we're going to do is reposition or reorient this alpha minus beta so that this terminal side coincides with the initial side, and then we'll put that over here in separate triangles. So we're taking this alpha and beta, rotating it down so that this part is now here, and this is labeled correctly as alpha minus beta. Now we know that this point here is 1, 0, and we know that the point on the unit circle that coincides with the terminal angle through the unit circle at alpha minus beta is cosine alpha minus beta for x and sine alpha minus beta for y. Okay, and remember this tool from previous math courses, the distance formula. So if I've got 2 points on a coordinate plane, the distance between them is given by distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so we're going to tap right into this. If we look at this, since we've rotated this piece so that this coincides with the initial side, the distance from here to here is the same as the distance from here to here. So I'm going to plug the distance formula in for this scenario and equate it to the distance formula for this scenario. So we're going to start with our 2 points as this and this. Okay, so that means that the square root of the x here minus the x here, so that's going to be cosine of alpha minus beta minus the x at 1, 0, which is 1, that quantity squared. It's going to be kind of lengthy, plus the y coordinate, which is sine alpha minus beta, minus 0. So I'm just going to leave that off. I'm not going to put minus 0, but the y is 0. Okay, so that's going to calculate the distance from here to here, and we're going to equate it to the distance from here to here. It's going to be a little different. So in fact, I might need some more room. We'll see what happens here. Okay, so I'm going to take the square root, and this time I'm taking cosine alpha minus cosine beta, the x2 minus x1, squaring it. So that's going to be cosine alpha minus cosine beta. X2 minus x1 quantity squared plus y2 sine alpha minus sine beta. Squared. Okay, so we've set up the distance formula, knowing that the distance from here to here should match the distance from here to here. So this is our B, and this is our A. All right, so now what we want to do is square both sides. Okay, so that makes it even more interesting. We can now say I'm going to bring it over here. We're just basically now going to get rid of the radicals on both sides, and we're going to have the cosine of alpha minus beta minus 1 squared plus the sine of alpha minus beta squared is the same as cosine alpha minus cosine beta squared plus sine alpha minus sine beta squared.
Oh, Andrew?
Okay, so we're going to expand all this out and simplify. So we're going to do a lot of squaring a binomial. So I've got this one term here, and if you remember, if I take an A plus B and square it, square of a binomial always comes out to A squared plus twice the product of A and B plus B squared. And if I have A minus B squared, we'll get A squared minus twice the product of A and B plus B squared. Okay, this would be what always happens when you FOIL a binomial with itself. Okay, so what we want to do now is multiply all these out using our binomial, square of a binomial pattern there. We can make it a lot faster. So we're going to take, this is like A minus B for 1. So I'm going to take A squared, which is cosine alpha minus beta squared, or cosine squared alpha minus beta, minus twice the product of A and B, and so that's just a 1, so this will be minus 2 times cosine alpha minus beta. Okay, and then plus B squared, so that's going to be plus 1 squared. Now when I square this out, since we subtracted 0, we didn't really change anything. We're not squaring a binomial here, we're just taking the A part squared, so we'll call it sine squared alpha minus beta. All right, so that side is expanded out. Let's expand these guys out. So we're going to have cosine squared alpha minus twice cosine alpha cosine beta plus cosine squared beta. All right, this last one, sine square alpha minus 2 sine alpha sine beta then plus sine square beta. Okay, so now we're going to use the Pythagorean identity. If I can find pairs of cosine and sine square for the same angle, I can substitute with a 1. So alpha minus beta is the same angle. So then I have a cosine squared alpha minus beta plus a sine square alpha minus beta. So all that, we just get it, turn it into a 1. And then I've got another one over here, so 1 plus 1, and then minus 2 cosine alpha minus beta. All right, so let's just clean that up, call it a 2. All right, and then over here, we've got a cosine squared alpha plus a sine square alpha. So if I put these two together, I get a 1. And then I've got a cosine squared beta plus a sine squared beta. So put those two together, get another 1. And then I have minus 2 cosine alpha cosine beta. And minus 2 sine alpha sine beta. And again, I'm just going to change this 1 plus 1 so I don't have to create a whole new line. And 2. Okay, a little bit left to do here. I've got a 2 sitting on both sides. So if I were to try and subtract the 2 from both sides, both of those 2 are going to go away. And all I've got left is negative 2 cosine alpha minus beta is equal to negative 2 cosine alpha times cosine beta minus 2 sine alpha sine beta. Okay, and notice that every one of these has a negative 2 factor. So if I divide both sides by negative 2, then this is going to turn into what we're looking for. So those are all going to become positive 1. So I end up with the statement, the cosine of alpha minus beta is equivalent to cosine alpha cosine beta that becomes plus sine alpha sine beta. Okay, and this was our formula. Okay, so we're going to see that it's pretty easy to come up with the sum formula. So we came up with the difference formula, and we need the sum and difference formula. So we're just going to take this cosine of alpha plus beta, and we're going to rewrite it as cosine of alpha minus a negative beta. Okay, so if I change this to that, I can go either direction. And we've got this rule now that we can apply when we're taking a difference. So we'll write this as cosine alpha cosine negative beta plus sine alpha sine negative beta. Okay, so I'm just slipping this into that. And we're thinking of beta as negative beta. And we know from the even nature of a cosine function that the cosine of negative beta is equivalent to the cosine of beta. So this part just gets to become cosine alpha cosine beta. Okay, even function, but an odd function, this is going to bring the negative out front. So this is going to be plus the sine of alpha times the negative sine of beta. Okay, and we can just move that negative out here and make it subtraction. So we can conclude that a cosine of some alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. Okay, and now we have our sum and difference formulas.